The example in F is a bit of a complicated derivative, and if we were to apply the L'Hopital's rule, it would be a little bit challenging. But we can simplify this a little bit by grouping them into some parts here. So I've got a sine, I've got a polynomial, I've got a cube root with an x and e to the x. Well, the cube root of x can be kind of grouped with the polynomials. So we're going to do this. So the limit as x approaches 0 from the positive side, we're going to group the sine x with the cube root of e to the x, and we're going to group the 2x to the 14 plus 3x squared with the cube root of x. Now, the reason why we might want to do this is, first of all, this part of the expression, so this part of the expression here can be simplified using powers, the exponent rules. And this part of the expression here, well, if we let x go to 0 from the positive side, well, the denominator is actually not 0, so we don't actually get a 0 in the denominator, and we can evaluate that part of the limit. So if I simplify this, I end up with limit as x goes to 0 from the positive side of sine x over the cube root of e to the x. When I plug in 0, that's going to be equal to 0. And then I also have this part here times, and this is just going to simplify to 2x to the power, and it's going to be, what's that going to be? 42 over 3 minus 1, so 41 over 3. Okay. Now, the actual power becomes irrelevant because we can cancel out the 0 in the denominator there. So we end up with, that's going to be 6 over 3 minus 1, so that's going to be 5 over 3. And this part now has no divide by 0. This portion here doesn't have a divide by 0. So evaluating this limit now, this becomes 0. That portion, we can find the limit independent of the red portion. And this portion becomes 0. Okay, so we end up being able to evaluate this limit in this way, and this is going to be equal to 0. So the limit is 0. And this one here, if we may want to apply L'Hopital's here. However, before you try to apply L'Hopital's, you would have to probably simplify this expression or group this expression, and to make it easier to differentiate, because differentiating this whole expression would be very messy looking. One last thing is that when we do limits, when you're checking your limits, see if you've done it correctly, you can always check by graphing. And I really encourage you to check your limits by graphing them and see if they actually work out.